let's just have a look at how the architecture differs from traditional storage. I'm going to get my pencil out now and start drawing, so please bear with me because drawing with a mouse isn't easy. So let's just draw a traditional storage filer. This could be a SAN, but let's think of it as a NAS for the minute because it's the most natural comparison. So we've got two heads, two controllers, controller 1, controller 2. We've got CPU resource in here. We've got cache, and we've also got obviously the front end host ports. Usually 2, sometimes 3, rarely 4, but we'll draw 4 here. And then at the back we'll have a, sorry, this is going to look messy, a disk tray, an area of disk storage. When you want your data, we're going to come in to one of these controllers, make our request for a file, and then we're going to pull it out of the disk tray, back out through the same front-end ports onto the network. And the processing power that's involved in doing that is delivered from the controller here. So the intelligence layer is this layer here. And in some cases you can run these controllers active-passive, and rarely, with some of the later models, you can run them active-active. But in terms of load balancing and host port utilization, really that comes down to some fairly complex client-side load balancing software that you can install on your servers to make that happen. And traditionally, really, that sort of thing is SAN technology. So from a traditional network-attached filer-based platform, you would be using one of these controllers at any one time. And then also, in addition to this sort of singular intelligence layer here, we're going to carve this filer up into logical volumes. And let's say that we've got, I don't know, let's say a 10 terabyte storage filer here, which is a fairly modest and quite a small environment nowadays. We're going to have to separate these volumes into something reasonable, something manageable, and they tend to be 2 terabyte volumes. I think with NetApp and with EMC Solera now you can have 2, 4, 6, 8, or sometimes up to 16 as a maximum volume size, but there are some fairly well-enforced maximum volume sizes, and each of those volumes has to be managed from an administrative perspective. So we've got snapshot policies, we've got obviously underneath these volumes we've got RAID groups, so you're going to have to use your RAID manager to build your RAID group out of the available disk pool. Then we're going to build a logical unit on top of that, and then on top of that we're going to add a volume. So there are various different layers of complexity, layers of granular configuration required, and then what we'll do is we'll give each of these volumes a share name. So this may be the C drive, this might be a D drive, just for sake of argument, and this might be E drive. So you end up with these little logical separate storage volumes that are presented to the network as network shares, traditionally over CIFS, which is Common Internet File Sharing protocol from Microsoft, or as NFS, which is a Unix or Linux technology. But they will be presented over traditionally gigabit Ethernet as logically separate volumes of storage. And obviously, you're quite quickly going to fill up a 2 terabyte volume, or even a 4 or 6 terabyte volume if you're using lots of large files, or you're working in a high-performance computer or a media environment, for example, or as a lot of people are nowadays, working with large virtual infrastructures which create big VMFS volumes or big NFS data stores underneath VMware and Hyper-V. 2 terabyte volume is just not going to be big enough for most people's virtual infrastructure to run happily within. And then you've got lots of segmentation, multiple instances of NFS data stores, multiple VMFS volumes, and it just makes managing virtual infrastructure more difficult than it should be. So this is your traditional architecture, and what happens is we can continue to add disk down here. As with most platforms nowadays, we can add JBODs or shelves of drives to these systems and expand the disk pool. In some cases, up to and over 100 terabytes, not a problem. But what you can't do is add more performance. You can't add more host ports, you can't add more CPU, and you can't add more cache typically. or if you can, it's very small increments and it's limited to a one-time only upgrade. So what happens is very quickly you bottleneck these incoming host ports here, and there just isn't enough bandwidth or processing power, relative to the amount of storage that you've got in the tray here. And also this logical segmentation and granular configuration and management just gets worse and worse and worse the bigger the system grows. And this is something that possibly you've not really considered as being an issue up to now, because maybe you don't know there's an alternative to this type of architecture. And actually in some cases, more with SAN than NAS, if you're running physical machines for Exchange and SQL and Oracle and you don't want to virtualize those machines, then a physical fiber channel traditional SAN architecture is more appropriate for you than Isilon even. But where we're talking about virtual infrastructure or file-based workflows, even and especially, in fact, Exchange and SQL and Oracle, when you're virtualizing those into virtual machines on top of VMware or Hyper-V, there is a much better way of doing this at the storage layer, and I'm going to take you onto it now. But it's not very flexible. It's fairly scalable in terms of capacity, but it's not in terms of performance. So you've got this non-linear scalability. It's very heavy in terms of time and management. So typically, it takes one storage admin guy to manage, let's say, 10 to 15 terabytes of NetApp. So every time you increase your storage capacity by 10 or 15 terabytes, you need another storage admin guy. And if you're paying that storage admin guy 40K a year, and maybe there's additional overheads there as a business, not just the straight salary, then it's a big operational cost to bear in mind.